Often when we're working with quadratic functions, the context will be money, and this is an example of where we have a couple of functions related to a business, and you'll notice that in both cases the leading coefficient of the n-squared term is negative. So as soon as we see that the leading coefficient of a quadratic is negative, we know that we are looking at a function that opens down, which makes sense since the majority of these problems will be asking you to maximize a value. It might be maximizing or determining the maximum height of a ball that's been kicked or punted, or an arrow that's been shot, some sort of projectile, because that follows a parabolic path. With money, it's maximizing profits or maximizing revenue, and that can be based on different characteristics of the situation. In the problem that we have here, I gave you two different scenarios, or it's the same sandwich shop, two different functions that we're going to look at. In the first one, the data has been used to develop a profit function for a local shop. And here's our function, P of n. Remember, it doesn't have to be x. It can be any variable in there. When I go to Desmos, though, I'm going to change all my n's to x's. So P of n equals negative 0.001 n squared plus 2.45 n subtract 525, where n represents the number of sandwiches sold. It will not always be a number. It could be the price of the sandwiches that are being sold. Don't think that every problem is done the same way. You have to read the context and determine what is that variable representing. So n is the number of sandwiches. Let's write that down. N equals the number of sandwiches. What is the maximum profit, and how many sandwiches should be sold each week to reach that maximum profit? Now, I hope when you think about quadratics and you think about a maximum or a minimum, that you're associating that with the vertex. So the vertex will tell you the maximum if it's opening down, or the minimum if it's opening up. So we have one that's opening down, and we want to determine what is the maximum profit and how many sandwiches should be sold each week to reach that maximum profit. So we're going to find the vertex. So x will equal negative b, which is negative 2.45 over 2 times a, and that will be 2 times negative 0.001. And that x value, I have my notes right here, that x value is 1,225. Then to find the y value, or the f of x value, we're going to substitute, and actually this is n. We think in terms of x, but that is n. So we're going to substitute 1225 back into the profit function and find P of 1225, and that will be negative 0.001 times 1225 squared plus 2.45 times 1225, and then subtract 525. And this ends up giving us 975.625. So I have found the vertex, and it is 1225 and 975.625. And I put it in Desmos for you. Let me uncover that so you can see the graph. It's a tiny little graph, but this point, which is our vertex, is the same numbers that I have here. But what we have to be able to do once we find that vertex, whether we find it using the algebra or whether we look at the graph in Desmos or in a graphing calculator, is interpret what does that mean. So this point corresponds to 1225 on the x-axis and 975.625 on the y-axis. We have to answer two questions. What is the maximum profit? Anytime that you are using a quadratic to maximize something, you've got a quadratic function and you're maximizing, always remember that the x-axis is going to be the x. So we've got p of n, in this case it's going to be n, but our function is in terms of x. It's in terms of how many. The quantity that we are maximizing is our y coordinate. That is always our function itself. So going up the y-axis, that is p of n, and that's what we are maximizing. So how many, first, what is the maximum profit? The maximum profit is the y value, so that will be $975.63. And then how many sandwiches, or when we were kicking balls, where does that happen? Remember that this x-axis is how many. So we need to sell 1,225 sandwiches each week. That's part A. Now let's look at part B. I'm deliberately covering up the graph just so we're thinking about the algebra before we look at our graph. So this is a different function, same sandwich shop, but now we're looking at the revenue. Not how much profit, but just how much money is coming into the sandwich shop every week. So that function is r of n equals negative 0.001 n squared plus 3n. Again, find your vertex. So n, which is x, is equal to negative b. That'll be a negative 3 over 2 times negative 0.001. And that value, when you put it in your calculator, equals 1,500. And then when I go in and find r of 1,500, by putting that into my function, I find that that value is 2,250. I'm not going to go through all the arithmetic on this one. So we're going to look at our graph. And now as we look at that graph, remember that we have to interpret what this vertex tells us. So on the x-axis, we have the n, or how many, and what we are maximizing is revenue. So this is revenue going up the y-axis. So that tells us when we look at that vertex. So our vertex is 1,500, 2,250. The vertex tells us that our maximum revenue for this sandwich shop, the maximum revenue is what we're maximizing. Remember, I told you we're always maximizing up the y-axis, so that means our y value is going to be our maximum revenue. So that is $2,250. And how many sandwiches need to be sold in order to have that maximum revenue? The number of sandwiches are on the x-axis. Sell 1,500 sandwiches. So as you are reviewing for your final, make sure you spend time thinking about what the the various parts of the function tell you. You've got to be able to interpret a vertex and know that when you're looking at a vertex, so let's just make a general little vertex here. The vertex gives you, if it opens down, so we've got a parabola that opens down, it's going to be an x, y, and that's going to be where the max is, and that could be how many sandwiches, what price, whatever we have on our x-axis. The y-coordinate is going to be the maximum of whatever your function is, maximum profit, maximum revenue, maximum price.